So the last remaining bit we have to do with 10.6 is classifying conic sections based on a general second degree equation, and then taking general second degree equations and putting them into standard form of the different conics. So this is a general second degree equation. You have ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. And this also has a discriminant like quadratic functions have, and it's also b squared minus 4ac. And we can determine the relationship of all the different variables and which type of conic it is by evaluating the discriminant. So if we take b squared minus 4ac, we can compare it to these rules. If it's greater than 0, it's either a circle or an ellipse. And we can then look deeper and see if b is 0 and a is equal to c, then it's a circle. But if either b is not 0 or a is not equal to c, then it's an ellipse. If b squared minus 4ac is equal to 0, it's a parabola. And if b squared minus 4ac is greater than 0, then it's a hyperbola. So when you have a general second degree equation, you can use this and determine which of the conics it is. Then we'll move on to putting it into standard form. So when I work with an equation, it would look like this. I have 4x squared plus y squared minus 48x minus 4y plus 48. Now if you look at b squared minus 4ac, so you see b is the coefficient with xy, and there isn't one, so that's 0. Minus 4 times a, that's the coefficient with x squared, that's 4, times c, that's the coefficient with y squared, that's 1. So I end up with negative 16. The negative 16 is less than 0. So if I go back, I can see that when it's less than 0, this is either a circle or an ellipse. And I need to determine, was a equal to c? Well, a was 4 and c was 1, so they're not equal. A is not equal to c, so this would be an ellipse. Right? So classifying conics just is evaluating the conic and finding out which of the shapes is it. Now if I want to put it in standard form, what I need to do, again, standard form involves the squares of binomials. All of the conic sections have the square of a binomial within the standard form. So if I start to rearrange my equation so that my x's are together and my y's are together, I can have 4x squared minus 48x plus y squared minus 4y, and then I'm going to move the constant to the other side of the equation, equals negative 48. And I'm a step on the road to creating standard form of this ellipse. Now, I have part of a perfect square of a binomial and part of the perfect square of a binomial. So I'm going to return to the skills I learned in chapter 5, and I'm going to complete the square for x and also for y. So I know I need a leading coefficient of 1, so I have to factor a 4 out of this. And then I need to add the correct item on here. Well, I take 12, I divide it by 2, that's 6. And then I square it. 6 squared is 36. And over here, I take 4 and I divide it by 2. 4 divided by 2 is 2, and I square that. 2 squared is 4. Now, you might feel like I added 36 and I added 4, so I need to add 40 over here. But in reality, because the 36 is in these parentheses and it's being multiplied by the 4, I really added 4 times 36. So 4 times 36 is 144. And here I did indeed add just 4. This becomes 4 times x minus 6 squared plus y minus 2 squared is equal to negative 48 plus 144 plus 4 is 100. Now my ellipse has to equal 1, so I'm going to divide everything by 100. And I end up with x minus 6 squared over 25 plus y minus 2 squared over 100 is equal to 1. And that is my conic section in standard form. So another example, I'm going to start working with this. This time I'm not going to classify it because I believe that if you start working with the equation to put it in standard form, it will become apparent to you what type of conic it is without having to do the b squared minus 4ac's. So I'm going to put my y's together, and I only have the one x, and I'm going to move the constant to the other side. Now, I have a variable squared and a variable to the first power. This has to be a parabola. This is the only case where this would happen. So now I know I'm going to complete the square on this side, but I need to move the x to the other side of my equation. So if I have y minus 20, I'm going to take 20, divide it by 2, that's 10, and then square it, that's 100. So here I'll have y squared minus 20y plus 100, and over here I have plus 100. This is y minus 10 squared, and this is 2x minus 94 plus 100 is plus 6. Now remember, I have to have a coefficient in front of x to the first power, so I factor a 2 out of everything, x plus 3, and now I'm in standard form for a parabola. So one last example, I am again going to put my x's and my y's together, so 9x squared minus 72x minus y squared plus 8y equals minus 119. I'm going to put these guys into groups, and also I'm going to factor this 9 out of both x terms. So I'll have 9 times x squared minus 8x minus, now when I put parentheses on here, I'm going to change sign, so minus y squared becomes plus y squared, and plus 8y becomes minus 8y equals negative 119. I'm going to complete the square on both of these, so 8 divided by 2 is 4. 4 squared is 16, so I add 16. And the same over here, 8 divided by 2 is still 4, and 4 squared is still 16, so I'm writing in the same value here. Equals negative 119. Now, I added in 16 here, but it's being multiplied times 9. So actually I'm adding in 9 times 16, which is 90 and 54 is 144. And here I'm adding in 16, but it's being multiplied by negative 1, so I'm actually adding in minus 16. Right? When I combine all of these terms on this side, 119 and 16 becomes negative 135 plus 144 is 9. Over here I have 9 times x minus 4 squared. I completed the square. Minus y minus 4 squared. And the last thing I need to do is put it into standard form by dividing by 9. This is a hyperbola because I have the minus sign. Sorry, I knew that all the way back here when I arranged things. Minus sign between the x's and the y's means it's going to be a hyperbola. When I divide everything by 9, I'll get x minus 4 squared over 1 minus y minus 4 squared over 9 is equal to 1. Okay, and that's the last bit of information you needed to get from 10.6. All the other information we had worked in along with sections 2, 3, 4, and 5.